I have a kicker who is kicking a football, and I'm using this equation that's given to me right here. Now it says H and T, so I'm simply, remember, this just means Y, and this is X, and this is X. Remember, this is the A, this is the B, and I have no C for this quadratic equation. And I'm going to, right away, noticing the A is a negative 16, I know that this parabola is going to open downwards. So very quickly in my calculator, I'm going to put that in. Let me clear this out. I'm going to go to my Y equals button. I'm going to clear that out. I'm going to clear this one out. Remember to make sure, oops, wrong one. Second, make sure that none of these are turned on. All of mine are off. Now this fifth one says it's on, but we don't worry about that one. So I'm going to go back to my Y equals, and I'm going to type in 48, and instead of T, arrow back up, instead of T I'm going to use X. So 48x minus 16x squared. And when I hit my graph button, this is my parabola. Notice down here, you might be able to see it a little better, it's starting right here at 0, 0, of course, because he's kicking the ball. So over here on my graph, I'm going to draw that. It starts here, and it's going up, and it's coming down. And it could keep going, but it's really not for this situation, because it says that H, my y-axis, is my H, so that's going to be my height of the ball. And my X is my T, which would be my time. Should have told you what all this stands for, but it didn't up here. Okay? But we're kind of using our prior knowledge that if he's kicking the ball up and it's going over, this is our time, because the height will depend on the time. And I need to find out how long the ball was in the air. So I want to know from here to here. Well, I know this point right here is 0, 0, because when he kicked it, no time had gone by, and the ball hadn't gone up in the air yet. So that's a 0, 0 point. So what I need to find is this point here to see how long it was in the air, because this height is 0. So if the height is 0, this line represents the ground. So this is where it started on the ground, went up into the air, and came down on the ground. So to find out how long the ball was in the air, I need to figure out what this point is. And remember, that's our 0 or our root. So if I go to the calculator and to my graph, I am going to calculate. So I want second trace, and I want to find my 0. So I'm going to hit enter, and I'm trying to find the one over here. Remember, it says left bound. We've worked with this. So I need to get over the hump where it was very high in the air. So I'm going to keep coming down. Notice my Y's, 35, 35, 35. Now it's starting to get smaller, so that means it's coming back down from that vertex. I'm going to come a little bit more. And hopefully soon I'm going to start to see my cursor. There it is right there. I'm going to go up 1 because that's too close. I'm going to hit enter for my left bound, and then I'm going to come down until it passes that 0, and I'm going to hit enter again, and now it says guess, and we hit enter again. And it says the 0 is when x is 3, y is 0. So this is when x is 3 and y is 0. So remember, x is the time, and we're going to take it, this is in seconds, it should have really told us, and this is the height. So it took him 3 seconds that the ball was in the air, because it went from here to here, and we just found out this point is 3, 0. Now it wants to know what's the highest point. That's this point here. And remember, that's my maximum, and it's also my vertex. So what I'm going to do is go to my graph again, and this time I'm going to do second, calculate, and I'm trying to find my maximum because it's a downward parabola. I'm going to hit enter. It wants my left bound. Well, I'm not on the left side. Up here is my vertex, so I need to get this back over. So as I go up, I see my y's are getting bigger, 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 35, 35, 35. Oh, now they've gotten smaller, so I'm on the other side of the vertex, because remember they're symmetrical. Hit enter, and I'm going to come back over to the other side of it. 35, 35, 35. Now it's getting smaller again. I'm going to hit enter and enter again. And it lets me know here my maximum is when x is 1.5 and y is 36. So this point here is when x is 1.5 and y is 36. So remember, x is the time, so at 1.5 seconds, it is 36 feet high. So to answer this question, it would be 36 feet high. That's as high as the ball got when he kicked it. All right, now we're going to do another one. Oh, I jumped too far ahead. This time, we're talking about Bob diving into a swimming pool. His dive can be modeled by the function f of t, so this is function notation. I'm simply going to put it in y equals down here. Y equals 0.5 t squared minus 3.5 t, where f of t represents the depth of his dive in feet. So y is his feet, his dive in feet. I'll add that up here. T is the seconds after entering the water. So x is going to be time in seconds. So I'm just going to simply switch these to x, switch that to x so I can put it in my calculator. And I need to find out how long he was under the water. Now the A, remember this is the A, this is the B. So looking at my A, it's positive, which tells me that this function, this quadratic, which is a function, is going to open up. So I'm going to go down to my calculator, and I'm going to type in, go to my y equals, and I'm going to clear this out, and I'm going to type in 0.5 x squared minus 3.5 x, and I'm going to graph it first to see what it looks like. So there's my graph, and right at the x, right at the origin, I see that's where it comes down. So I'm going to kind of draw that over here. Kind of comes down like this, and it comes back up. Oh, I should have gotten rid of my calculator first. So it comes down and back up. Now remember, the x is his dive. Well, he's not diving up here. He's diving down here. So this is the feet under the water, and this point right here is where he enters the water. This is the water level. So this x is the water level. That's where he is entering the water. So he enters into the water, he dives down, and he comes back up right here. He's not flying through the air at all, so these we really don't need. We're just looking from here to here. It wants to know how long was he underwater. Well, we know he started here, where at 0, 0, no time has gone by, and no depth. He went down, and he came back up here. So again, I'm looking for that x-intercept, or that 0. So I'm going to go back to my calculator, and I'm going to go to second, calculate, and I want the 0. So I'm going to hit enter, and it wants the left bound. Well, I need to get over here where this 0 is. I already know this is 0, 0 right there. I'm trying to find out how long he was under the water, so I got to see from here to here. So I'm going to arrow over until I get close to this. Okay, and I'm going to hit enter, and then I'm going to arrow, it wants the right bound, so now I have to be to the right side of that 0. And there it is, and I'm going to hit enter, and enter again. And I get x is 7, y is 0. So when x is 7 here, y is 0, meaning he's at 0 feet in 7 seconds. So how long was he underwater? 7 seconds, because he went from 0 to 7. How far underwater did he go? That's this point, my vertex or my minimum. So I'm going to go back to my calculator, and I want to second calculate, And this time I want to find my minimum to see how far down he went. And it wants my left bound, and I need to be to the left side of the vertex. So I need to arrow back, and this one I can see. So my arrow back, it's going a little bit slow. There we go, hit enter. And now I'm going to go over to the right of it, because it wants the right bound. So the right side of the vertex. I'm going to go up a little bit just to make sure I'm up off the vertex. Hit enter, and it says, do you want to guess? We hit enter again. And I find out that at 3.5, y is negative 6125. So when this point here, x is, oops, sorry guys, got the wrong tool. So at this point here, x is 3.5 and y is negative, you know what, I'm going to bring it down here. 3.5, y is negative 6.125. So the question is asking how far underwater. So that's my depth, which is my y. So my y is negative 6.25. Now I'm not going to say negative 6.125. It says underwater. So how far underwater did he go? He went 6.125. Remember, that's in feet. Underwater. And I should have wrote this sentence up here. I know you guys are going to tell me later. He was underwater, because I always tell you, write a sentence. 7 seconds. Okay, now we're going to go to our last one. I know this video is a bit long. Here we have a function again. We're just going to say y equals. So I'm going to stick that in my graphing calculator to see what the quadratic function, I want to graph it over here. And then I need to find my x-intercepts, which are my zeros or my roots. So very quickly I'm going to put that in my calculator. Go back to my y equals. This one's taking a bit longer, guys, because I have to put in these equations. And we get negative x squared, and if you need to, you can kind of fast forward through this part as you put it in yourself. Negative x squared minus 4x plus 12. And I'm going to hit my graph, and right away, A is negative, so I know it's going to be opening downward. And they kind of already showed me the picture over here of the arches. And that's what it looks like. It's kind of coming in somewhere over here in the x-axis and somewhere here. So when I come over here, I'm going to kind of eyeball it. It's not going to be exact. And I need to find my zeros. So the art gallery has walls that are sculpted with arches that can be represented by this function. X is in feet, so X is my feet. The wall space under each arch is to be painted a different color. So I take it my height's probably in feet also, if they're both in feet. So my y is also in feet. I know it didn't say, and it should have. So this right here would really be the ground, because this is where the arches end, at the ground, when y is 0. The arches aren't going underground here, they're just going from here. So it wants me to find these x-intercepts. So on my calculator, I am going to go to second, calculate, and I'm going to find my 0. And it wants my left bound, so I need to come way over here. And as I watch it go, there it comes down my cursor. So I'm going to be on the left side of this one, hit enter, go up to the right side of that x-intercept. I'm going to find them one by one because this time it wasn't at 0, 0. Hit enter, enter again, and I get negative 6, 0. So my x-intercepts, this is at negative 6, 0. So over here I'm going to write it like this. Oh, sorry. Negative 6. And now I need to find this one over here. So I'm going to second, calculate again. I want to find the other 0, hit enter, and this time I need to arrow over, so I'm going to keep going. See, it's going up, my y value is going up, 15, 15, 15, 15, 15. Now it's coming down, so that means I'm coming down my parabola now. So I can start to look for my cursor. It should be down here. There it is. So I'm going to hit enter. I'm on the left side of it. Now I need to go to the right side of the x-intercept, and I'm going to hit enter. Enter again, and it lets me know x is 2, y is 0. So this point is at x is 2, y is 0. So my x-intercepts are at -6 and 2. It wants to know what is the length of the segment along the floor of each arch. Now we know this arch is really not, it could be at -6 if 0 is right here. So it wants to know how long is each of these arches. Well, they're the same. So if I'm going from -6 to 2, that would give me 6 spaces here and 2 spaces here. So that would give me 8 feet. So each length is going to be 8 feet as I continue this parabola all the way down, or the arches all the way down. Now I want to know what's the height of the arch. That's this point here. So remember, that's my maximum or my vertex. So I'm going to come back here and I'm going to second calculate. This time I want the maximum. Enter. And I need to come on way over here, and it wants the left bound. So I need to go up, make my y's go up, 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 up. Still going up, 15, 15, 15, 15, 14, 12. Now it's gone down, so I know I'm on the other side of my vertex. I'm going to hit enter, and right there that arrow shows me where I'm at. And I'm going to go back up and over, 15, 15, 15, 15, 14, 12. So now I know I'm on the other side. Enter, enter, and it tells me here x is -1.9 repeating, so I'm just going to round that to -2. Y is 16. So I've got for my maximum -2, y is 16. Remember, the y is the height, so the height of the arch is 16 feet. And that's how we use quadratics and parabolas in real life. We'll have more examples in class tomorrow. I know this was a long video and I apologize for it.